There are already systems which can detect when a person suffers from an accident, for example falls, but sounding an alarm after an accident happened is already too late. We want to go a step further and actually prevent the accident before it happens. One possible application is monitoring the elderly. In elderly population, falls are the most common cause for hospitalization and are very dangerous for the patients. The most common place where falls happen in Taiwanese hospitals is bedside. Most accidents happen when patients struggle to get off the bed. We can prevent falls if we detect patients' efforts to get off the bed early enough and inform the caregiver to assist the person in getting off the bed. We can raise the alarm that informs the caregiver that the patient requires aid in getting off the bed. So, we predict that the fall might happen and alarm someone in time to prevent the accident. According to research, this would be effective in preventing falls, as getting out of bed without assistance is a common situation in which falls happen in elderly population. However, nobody wants to be constantly monitored and recorded on videos. More importantly, capturing videos with a regular camera in public places such as hospitals raises serious ethical issues and therefore is prohibited. That's why our system uses a novel, privacy-preserving sensor. It only captures the temperature of the object. You cannot recognize the person in the image, cannot see their face, and, in fact, can only see a rough outline of a body, which means that the sensor preserves the privacy of the patient. We want to develop an intelligent system that uses thermal images to detect dangerous situations early and prevent the accident by sounding the alarm before it happens. We employ artificial intelligence methods to train the system to reliably detect as early as possible patients' efforts to get off the bed. At the same time, artificial intelligence methods minimize the rate of false alarms. We mount 3 thermal sensors on the ceiling above the bed. This way, the sensor is not noticeable and doesn't interfere with daily life of patients and caregivers. The sensors look at the patient from different angles. This is because actions will look different from different viewpoints, which gives more information to the system so that it can make more accurate prediction. The model can accurately predict that a person will attempt to get off the bed even before the actual onset of the action. Therefore, it raises an alarm very early, giving the caregivers time to arrive and help the struggling person. It can predict the dangerous situation regardless of whether the view of a person is occluded by some object, such as blanket. Its decisions are not based on whether the person is uncovered or whether they change their position in bed only. In other words, the model doesn't depend on some set of predefined actions which could precede the attempt to get up. For example, it doesn't matter if the person uncovers themselves, rolls around in the bed, or moves closer to the edge. The alarm will not be raised as long as the person doesn't make any actual attempt to get off the bed without assistance. Such sensors can be mounted above the bed in hospitals, nursery homes, and private bedrooms. They only collect information about temperature, so the privacy of anyone in a room with such sensors is completely safe. As you can see in the video, the sensor captures only an outline of a person, and it is completely impossible to identify the person in the recording. We already have preliminary results that look very promising. In our cross-subject experiments, the model can predict that a person has the intention to get up almost 8.5 seconds before they start getting off the bed. At the same time, precision and recall of the predictions are very high. Furthermore, even if the action is sometimes not predicted before it starts, it will always be detected overall, and the caregivers will still be alarmed to assist the patient. As the work is still in progress, we expect even better results in the future.